In this video, we are continuing with the observational study example. So in this example, we have 3 plants and our response variable is the scores on quality awareness examination. The hypothesis that we're testing is the average examination score is the same for all the 3 plants. And we looked at the factors and population and the assumptions in the previous video. Review the previous video for more details on that. So now we're going to do the test itself. So we have 6 examination scores from Atlanta, 6 from Dallas, and 6 from Seattle, from 6 employees each. And we need to summarize the samples. So first is sample size, we get that with count. Next is X bars, which is the average of each of these samples. And then sample variance is VAR dot S. So now we have the sample 1 summarized. Now we copy that across. So now we have the summary of all the 3 samples. Next is overall mean, which is X double bar. And that is the average of all the 3 samples taken together. K is count A of the 3 treatment levels, so that will be 3, and N sub T is the sum of the 3 sample sizes. So that's the total number of observations. Now SSTR, the formula is here, and we're going to split it up into smaller steps and then finally combine them all to get the SSTR. The first step is to find X bar of a given sample, subtract from that the grand overall sample mean and make that absolute reference and square that. Copy. So now we have that part done for all the 3 samples. Next, we multiply N sub j times that squared deviation. So that's the whole thing for the first sample. And we repeat that for the other 2 samples, and then you sum them all, then you get SSTR. Let's color code that as the final answer for SSTR. And SSE is n minus 1 for each sample times the sample variance. So you get n minus 1 times sample variance. Copy that and sum, and that's our SSE. Now we are ready to assemble these squares in the ANOVA table. The first one is SSTR, the second one is SSE. Degrees of freedom, first one is K minus 1. For SSE, it is N sub T minus K. Now take the sum of squares, divide by degrees of freedom. Okay, take the sum of squares, divide by the degrees of freedom, you get the mean squares. The first one is MSTR, the second one is MSE. So you divide MSTR by MSE, we get the F value. And then the P value is FDist.RT of the F statistic. Then the first degrees of freedom is for the treatments, numerator degrees of freedom, and then the denominator is error. So that's our P value. Now we can make a conclusion using this P value. But before that, let me demonstrate generating the same ANOVA table using data analysis. So, data analysis, and the very first one is ANOVA single factor. Now, you highlight the samples and the first row is labels. Now, let us put the output at a 50. Click OK, and that generates the output, which is the first. There are two tables. The first table is a summary of the samples, okay, and the second table is the ANOVA that we just generated, and you see the values are identical to what we generated using the formulas. Okay, the p-value is the same. Okay, F critical is the F table value, and we are not going to use the F table value. So, now the p-value is less than alpha. So, let us assume alpha of 5%. So, our conclusion is to reject the null hypothesis. Now, we have to provide an interpretation. So, since p-value is less than alpha, we can say that we have sufficient sample evidence to conclude that the null hypothesis is not true. That is, the mean examination scores for the 3 plants are not all the same. And the probability that we are wrong, which is type 1 error, is 0.27%. The next video, we look at one more example, and that one is an experimental study, and you will see that the procedure is almost the same. The only difference being at the time of collecting the sample.